Okay, this traveling salesman problem uses a different kind of graph. Instead of trying to make a circuit that uses every edge exactly once, we're instead going to try to do it so we're using every vertex exactly once. So this becomes a Hamiltonian circuit as opposed to a previous video which talked about an Euler circuit. And so the standard traveling salesman problem talks about somebody who has to visit several different cities. Now, I admit I originally had more cities than this planned, but I could only find airplane costs between these four. So what I have here is I have 4 cities: Augusta, Maine, Boston, Harrisburg, Pennsylvania, Columbus, Ohio. And I looked up some costs to fly from one to the other. And in this problem, we've got a businessman. He has to visit all 4 cities, and he's trying to do so in the least cost. And that's a kind of standard problem for a traveling salesman. Some of them will have distances instead of cost, but yeah, each edge now gets a number associated with it, and it is to do a Hamiltonian circuit, visit each point, each vertex exactly once, in such a way that the sum of all the edges traveled is as small as possible. Now, for a larger thing, if you tried to make a list of every possible circuit, it would be an extensive list, and it would take quite a long time, even with a computer. So instead, they've got 2 different ways. I'm going to talk to you about 2 different ways to try to solve this. And one way is called the nearest neighbor method, and the next slide will be the best edge method. So in the nearest neighbor, you have to start somewhere. So let's say we're starting in Augusta, and you just look at all the things exiting from it. So I'm looking at the 612, the 789, the 138. You pick the cheapest one. So I'm going to go 138. I'm now in Boston. I'm not going to return back, not right away. I have to visit the other cities first. So I'm looking at those 2 costs, 298, 302, and I go the 298. And now I'm not going to go to Boston, I'm not going to go to Augusta, so I'm going to go to Columbus next time. It's the only choice left. So 444. And because it is a circuit, I'm going to return back to the beginning. So that will be A to B to H to C, and just add those up. And that's my estimate for the least cost by the nearest neighbor algorithm. Now, these, if you start with a different city, you might actually get a different cost. So it is dependent upon what city you say you're starting out with. On the other hand, best edge, same graph here, but best edge, it doesn't depend on where you start with. As a matter of fact, it doesn't tell you what to start with. Instead, you start listing down the cheapest. Look at everything. What's the cheapest? 138 is the cheapest. Okay, so you write down A to B. And then you look at the next cheapest. Well, that would be the 298. So you write down B to H. Now, at this point, B has been mentioned twice. So you're flying into Boston, you're flying out of Boston, because you listed twice, A to B and B to H. So you can no longer use B. So you look for the next cheapest. Your initial thought is 302, but I cannot use B again. So forget about B. Otherwise, what have I got? I've got 432, 789, 612. So 444, excuse me. So 444 is the cheapest. So I'll go 444. I cannot use H because I've listed H twice. I've gone B to H and I've gone H to C. So the only thing left, I mean, I can't use B, I can't use H, so it's got to go C. So it's got to do the 612 here. And then the C has been listed twice. Now, when the A has been listed twice, you're done with all the cities. So you just have to take everything you've said and put them in order. Now, as it happens, this was in order. Went A to B, B to H, H to C, C to A. But sometimes in best edge, you have to rearrange to put them in order. Well, okay, that's it for Hamiltonian graphs and the traveling salesman problem.